Hello guys, so now we want to create the impact effects, and we want to shoot out a lot of debris and particles from the center here. And so we need a way of sculpting this the forces, because we're going to have a lot of points stacked on top of each other or in a very small region, and then they're going to get shot out and at a very high speed, and we need a way to sculpt that. So I have a simple workflow for this. I'm going to start with a sphere. Let's increase this. I'm going to make it smaller, and I'm going to add a mountain node to add some noise to it. So let's increase. This is cool. Let's increase the height, and let's lower this, and let's add some more. Okay, cool. And what we want now, so for example, this is our splash force, and this is how the particles are going to get shot. We can change this easily now by simply sculpting the shape that we want here. And then we're going to clip all the points, so only the stuff going upward is going to be left. And the idea is we want to scatter a lot of points. Actually, let's reduce this even more. So I'm going to put down a transform, scale it down. And the idea is we want to create a velocity vector that match this motion, this shape here. And the way to do that is by computing the difference on the point position between its original, for each point between its original position and the new position. And the way to do that is using by taking P here from the original shape, and then the deformed P, and computing the difference. So let's create a wrangle node. Okay, and I'm going to connect the second input, which is this shape, and each point has the same number, so we didn't change that. We can still reference each point and find where it is in the new location. So we're going to say vector new velocity, and I want to read the point position from the second, or let's say deformed points. I want to read the second input position, so that's going to be P point expression. The input number 1, which is this guy, we want to read the point attribute called P, and the point number is going to be the point at PTNum, and which means this guy is going to loop over all the points, and for each point here the expression is going to be run. This is going to be updated, so it starts at 0 and ends up at 5,000, whatever the points are, and it's going to loop over all the points and bring us back that attribute. So the velocity now is going to be the current position, which is V at P, minus deformed points. And let's take a look at this, and look at that. Now we're copying the velocity onto this guy. And if we use this, and let's clip the sphere, so we're only left with the top half. Like that. If we scatter points now on it, they will inherit that velocity. Let's say 10,000. And I'm going to connect this onto the second input, and we can actually leave this, we can move it aside for now, and create a new source, pop source, and we're going to say all points from the second input, and I'm going to use those. Okay, we're not going to worry about the first one. And you can see already it changed the first frame, and that's because the birth jitter is not set yet. It's set to positive, so we can say it's negative, and that will snap them and not check the frame ahead. So if we hit play, we're gonna get this. Okay, we don't need all this emission, we just need to emit for one frame. So I'm gonna say $f equal to 1. When this expression is true, return 1. If not, return 0. Means it's gonna be true for one frame only. Okay, So if we hit play, there we go. And I'm not sure why it's scattering on the bottom half. It could be that, yeah, some points are going downward for some reason, but we can fix that. We can add a pop scale. Or actually, let me teach you something else. So with, like we can do with the wrangle here and process the points, we can also do the same wrangling in pops. Okay, so let's dive inside, and I'm going to use a pop wrangle node. And this is similar to the vex wrangle, the attribute wrangle, but it's in dot context. So I'm going to say v at p if the position of the point on the y-axis is less than 0, remove the point using the remove point expression. Okay, may look complex, but it's actually very, very simple. This if is an if statement. If this condition is true, which is the y position of the points is less than 0, means below the ground plane, remove point. This is a vex built-in expression. Now, how do I know this stuff? Well, you can click the help button, and I can go to vex language. No, 1 second. Sorry, the vex, where is it? Yeah, vex expression, and then we get to the vex language reference. Let's try this. Okay, so these are all the this is the page. The vex function is what we need. Vex function / index. So here, this is all the vex expression that Houdini has, and this is what Houdini is built of, whether it's a shader or a wrangle here or a primitive wrangle, anything. All the information, all the calls that Houdini has are available here, so you can look this up and see and learn some new stuff. So if I type in remove point, this is the function, and you can see it says remove a point in a geometry specified by a geo handle. If point number is -1, nothing is done. So there is also a remove primitive if we want to delete that, and these are all point related, so you can add points and stuff like that. And this is how it works. Remove point, the geo handle, which is the first input in this case, and then the point number, which is at ptnum, and this gets executed when this function is correct. So let's go back, and now we're left with the top part only, and any point that gets go down, it's going to get deleted. Okay, so let's add some more noise to this. I'm going to use a random attribute randomize here, and I'm going to say v. I want to add more randomization to the velocity, and right now I'm gonna choose direction or orientation, and I'd like to use this cone angle thing. I'm gonna set the direction to be y position. Now you can see we're adding more randomization there, and we can reduce the amount of force we're adding to it. Okay, let's hit play. There is our splash, and the main thing that we need, that we're missing at the moment, is the impact here. So let's merge them together, and yes, we can do this. We can merge two chains, and let's actually merge the first one first, just to be organized. I'm going to move this, and then find the frame where this happens. So let's play the trail first. Okay, so frame 35. If frame is equal 35, emit. and I'm gonna reduce the number of points here so it goes faster. Let's go up in the trail, and let's say 100 points only. Okay, so it's working, and let's do some more tweaking. Again, now at this point, I don't have any more technical stuff to add. Everything is working. I'm gonna just spend time tweaking attributes. And again, there's not so much, to be honest, I can teach you when it comes to this. It's all artistic and like personal decisions that you need to make on how you want this to look like. Okay, and see this pop kill here, it's only in this chain, it's not going to affect this. So that's another benefit of doing this at the same time. Okay, so in the splash or the dust hit, I'm going to set the frame to 2, the life expectancy 2, and this 2.5, set it to 1.5. And I want to increase the velocity. I want to give it a velocity of 10. Make it 10 times stronger. Cool. And I want to add a pop drag on top of everything, and we need to move the gravity here down so it affects both chains. Okay, and the drag, I'm going to set it to 0.1. Cool. Yeah, I think it's working. So let's give it some more velocity to go up. What I'm going to do is I'm going to say add inherit to inherited velocity. I'm going to give it 4 in the up vector, and I'm going to add some randomization as well here. And this way it's going to go up more. And I want the particles to live longer. Let's say 3. And I want to increase the velocity a bit more, so 2 times. Yeah, cool. Okay, let's go down, and I want to increase the point count to, let's see 100,000. See how that looks. Come on. Houdini is freezing at the moment. Play. All right. That's our impact. Okay, I want to make some more changes. So first of all, I'm gonna make the original sphere smaller. And if we do this, remember that we're computing the difference between the points. It's going to also change the velocity vector. Okay, so it's going to increase or change the amount of force because now the distance between the points is different. So we have to keep that in mind. And I want to change this shape a bit. I'm going to lower the element to add more spikes, and let's increase this. Let's increase the frequency. Okay, cool. And let's add more. Let's lower this even more. Cool. So more variegation. And another thing I want to do, see, this is slow now, the relaxation. I'm going to turn it off. I don't want the points to be well distributed. I want them to be on top of each other. Okay, it's very small. Why is this? Let me close the viewer. Sometimes it gets flaky. And let's reset the clipping plane. Yeah, it's very small, so okay, those are the points. I'm gonna add a noise, and I want to delete a couple of points. So I'm going to create a point file, and just to make it easier to see, I'm going to add a transform and scale this. I'm not sure why the viewport is flaking. I'm going to scale this by 10. Yeah. And let's dive inside, create a noise. Let's plug this into the color and increase the frequency. More. Even more. Something like that. I'm going to copy this, and I'm going to compute the absolute values, because right now there is negative values. Yeah, let's do that, and let's multiply all this by another noise just to add more breakup to this pattern. So let's lower this. Okay, let's add an absolute node. Cool. And I'm going to delete everything except the white points. So I'm going to put down a blast node and say at cd.x is less than 0.5, which means if the red color is less than 0.5, delete the points. And if we look now, we should see less points. So 1 million here. After the delete, it's still 1 million, so let's make sure it's set to points, and we can see the gaps now. That's what I want. And I'm gonna add this here. I don't need the transform, I want the points to be there. And let's take a look and see how it looks like with 1 million points being emitted. Yeah, see, now we got a lot more breakups happening. Cool. And I'm gonna copy, let's see, this. I'm gonna copy this, add it here. I'm gonna copy it one more time and set the amplitude to 2, set the scale to 5. I just want to layer couple them, that's all. That's 2.5, frequency to 4. And I want to give them a, want some color on the sphere. So here, on this guy, I'm gonna, actually it's inheriting this color, so I don't want that. I'm gonna create another point fob. Let's copy that, and I'm going to set this to 3D noise, this to 3D noise, and we'll use this color. I think that's fine. I think the noise here, the randomization that we did is changing them a lot, so let me turn that off. Yeah, see, now we're getting much sharper trails. That's because we removed the noise. We can add it back, but I don't want to break these lines a lot. Cool. Okay. So now I'm liking the result and everything. The only part that I don't like too much is the emission part, and I don't want to delete them if they go below 0. I want to delete them if they go below -1. And I'm gonna add a ground, and I want them to collide with the ground. Okay. Cool. So now the ground is gonna take care of everything pretty much for us. And I'm gonna use this to create something else. And this is a very, very important topic that hopefully I'll be able to give you guys a lot of ideas about it, but the concept of layering effects on top of each other. Okay, let's go back up, and I'm gonna say dot import, and let's import all these guys. Pop object, fetch geometry. I want to fetch my geometry data. Cool. And I'm gonna increase the frame range to 40. And I'm gonna do one more thing. So inside here, I'm gonna select the pop solver. If we go under collision behavior, right now it says enable collision detection, but that's it. There's nothing else. I want to check on add hit attribute, and I'm going to say I'm going to leave the default behavior. Actually, no, I'm going to change the behavior so that when it hits the surface, I don't want it to bounce anymore. I want it to slide along the surface. And then I want to change, let's see, collide group. So I'm going to create, when it collides with the ground, I'm going to call it, I'm going to group the points and give them I'm going to group the points under a collide group. Okay, and let's dive back in, hit enter. We're not going to see a huge difference, but I need this information to do to create a secondary layer that I want to show you guys. Again, I don't have a clear idea of what the visual result may look like, but I think the concept will be given. I think you guys will understand the idea. So let's go back up, and now if I middle click, I should see a collide group. Now let me delete everything except the collide group, and look at this. Let's hit play. Nice. So now we're isolating only the points that have hit the surface. Okay, and they're sliding along the surface. And it looks like the ground is quite small, so let's increase it a bit. And I'm gonna lower the point count here so it runs faster. Say 10,000 points. Hit play. And those are the points that are colliding with the surface. Again, the result is not very obvious, so we may have to do it with a lot of points. Let's try 3 million. Yeah, it's much better now. Okay, so I'm going to lower this back to 1. I'm going to write out the cache, and I will show the idea that I want to create, or the concept, in the next video, and hopefully you guys can create something out of this. Let's call this dust hit. I'm not sure if it's dust hit, but yeah, call it that. $frame. I'm going to cache 150 frames. I'm going to leave all the attributes for now. I don't care too much. And I'm going to turn off caching. And let's save. Cool. We'll continue in the next video. Thank you guys for watching, and see you in a bit.